Well, good afternoon, everybody, and I'm glad you all stayed for the afternoon session. It's great to see a lot of faces out there in the last day of the symposium. So I sort of hodgepodged a bunch of different topics together here, so you're going to have to kind of bear with me, and we'll go through some different ideas. But I've spent the last 18 months actually out selling broadband antennas, and it's been a really interesting experience, and so I hope to give you some of that, and then talk a little bit about some of the design parameters that we've been doing. You just saw an example of one of those, so I thank Merrill and Nick and the folks at Dielectric. So the industry's really been helping us out to make these systems work for our customers. So a shout out to them. So let's see. So today we're going to just kind of go through the sort of the effects of the repack on American Tower, and what we've been doing up to date, and some of the challenges we face, both from a timeline and then just the implementation in general. Talk about the antennas we have now and what's happening to those, and then talk about our new program and what we're trying to do there, and then get a little into this new antenna technology known as dynamic polarization, and it's a really exciting new technology that we're excited to bring into the market, and I will show you a market that we've been working on and sort of how that came together. So I think after 3 days, we all know there was 987 stations needing to be repacked. We've probably seen this 15, 20 times today over the last 3 days, but American Tower had 217 of those on 133 of our towers. So it's a pretty large impact to our business, not to be underestimated, and was not underestimated by our team. And we've been working pretty hard for the last couple of years to try to stay ahead of the repack. The other thing that's important is that there was 175 winners in the auction, and 52 of those were on our towers. So that's also can't be underestimated, the impact of that. Even removing stations from towers, while it appears it's always good to take a load off a tower, it doesn't necessarily work out that way when you do a structural analysis. So all of those things are important. 8 of our auction winners went from UHF to VHF. That's sort of a lo and behold kind of announcement that, by the way, you had a relatively small UHF antenna, and now you need a nice, big, heavy VHF antenna. So we had 8 of those. And 44 of those are going off in the next 6 months. So it's all happening pretty quickly. So we've heard a lot about the 39-month timeline. So I'm here to say it's not a 39-month timeline, guys. It's this is the impact on us as far as timing. We will have work that has to be done on 15 of our 15 stations on. So this chart, what this chart has is the sites here on the left, and then the number of customers on those sites. So in many cases, the number of sites is less than the number of stations. Obviously, we share towers, right? So what we've done up here, you'll see we have tried to categorize by an inventory of these 133 towers what the impacts on each of those towers is going to be. So we have these, what we call type 1, where we're really hoping not to have to do tower or site modifications. Station comes along, they change out their antenna, life goes on, everybody's happy. You can see that, you know, there's a few of those, and that's a good thing. And then there's the type 2, which are what we call moderate. We don't have to rebuild a whole lot of the tower, but we do know there's going to be modifications necessary on the tower. And then our favorite ones are the type 3s, which those are either candelabra type towers or heavily loaded smaller towers. But basically, these towers are going to be complex projects. Lots of tenants, might have a BBA, which I'll explain what that is. And there's going to be major rigging and renovations. So you can see we survived phase 1 without any of those projects, at least hopefully. But we have a number of those in phase 2. So LA being one of the chief amongst the phase 2. I should say these dates down here, by the way, are not the cutover dates. These are the test dates. So for our work, we are planning on test dates being ready, not the cutover date. Obviously, every site is site by site when they are actually going to switch over. But we'd rather be ready earlier than later, as I know everybody wants to be, would rather be later than earlier. So this gives you an idea of how our sites are going to fall. So there's a lot of work early on, and in fact, as I said, the peak is actually next year. So as I said, we've been working hard. Quite a bit of this came out of some of the releases and information we've given to the FCC. Kind of, we visit them pretty often, giving them updates. We have been doing a lot of work understanding the situations on our towers. We've done over 100 mappings. We have scrubbed all our equipment that's on the tower and the steel. So we have a collection of towers that we've acquired through different means. Some were built, but not very many. So when you acquire a tower, you may or may not get a good set of data. So this DNA is critical when you're doing a structural analysis. You have to actually know every member in that tower, or you can't run a structural analysis. So that's been happening now with towers that we didn't have good DNA. We went back and said, you know, please measure this and check this member and let us know what it is. So once we had these audits, we were able to go out and do, with our own structural analysis engineers and then using a lot of third-party resources, we could actually run a structural ahead of time with what we thought might be a load scenario. And that's, you know, we actually spent 3 weeks going through our entire list of towers that we knew was going to change and saying, well, this is about the worst case, or this is what we think might happen. And we actually had a baseline structural run. So, and we also did some scope of work for our services group. We are putting in place, hopefully, our goal was to have it be easy for our customers to change their operations on our tower. I mean, we really want the easy button. So some other things we did, over here on the right, we took the 399 form, which most all of you are familiar with, and we made our own version of it. And we incorporated all of the stations on a particular tower, and we aligned all of the costs on that tower and then divvied it up per the Widelity catalog. to each of those stations, or if we knew what equipment, then we were able to put that in. So we did all of those Form 399s for anyone who asked for them, and some who didn't ask, but we gave it to them anyways. And so we did that for all our towers. And we have a team in place, and we have about 30 members on our repack team who are kind of at our disposal. We did a new lease form that's already in use. And something I'm reminded of by my sourcing people all the time is we went out and bought almost $4 million worth of equipment, which is now in inventory. And I'm sure you know, no one likes inventory hanging around. So I keep getting asked pretty much every week, when are you going to use that stuff? So we also went out and hired several vendors and started doing a lot of work around setting up our vendors. And I've had several consultants also doing coverage work for me with our broadband antennas. So just kind of a laundry list of challenges. I think you guys have been hearing about this through the week. Obviously the budgets, need to get released soon. The stations are cautious to begin, and they're concerned over the upgrades. I think that's pretty well in hand. And the other thing that's happening right now is maximization. Nick was alluding to that, and until some of that maximization and the stations can't commit to the antenna. I mean, we've known all these things were going to happen. It's just, it's all out there coming together. But, one of the things we also see is the schedule, didn't take into account weather. That's certainly a concern. And these are just things we're going to have to deal with. And what also, I've spent a fair amount of time talking about is construction delays that might be imposed by non-repack stations. And I really emphasize to all of you who are being repacked, make sure you go out and communicate to other tenants on the tower who aren't repacked. Understand their positions and understand how you might work together with them. So I will say these challenges on large candelabra and multi-tenant towers are multiplied when we have 5, 6 customers all needing to move. Doing overnight work with RF suits, we've had customers come to us and say, we got it all in hand. We got a tower crew, they're gonna work on suits. Don't worry, they'll get 4 hours a night. Those kind of plans are not gonna work on a community tower where we're got to change out 5 antennas with 5 transmission lines. And so that's hopefully my advice is to, so I also wanted to get up on since I'm up elevated, I'll get on my soapbox. I started in the broadcast business now 30 years ago, and when I started, my boss said, there's only about 10 years of over-the-air left. So don't sweat it. Over-the-air is going away. It seems like every 10 years I hear that story again. And that's really why I put this up here. Don't undervalue your off-air signal. And we're finding, as we go around the country, we're really trying to encourage engineers to pass on up to management. Don't undervalue your off-air. Cord cutters are happening all the time, and you're going to need an alternative as an interim. So, start planning now and getting management to understand what's going on. And then The other thing we're seeing is just the minimal value on permanent auxiliaries, and that's that's been something we've been dealing with. Is if we're going to put an interim antenna up, why take it back down? So that's my soapbox. I'm done. So American Tower, as we said, it has a whole bunch of these antennas. This is Merrill's 2 antenna that we have in LA, and that's one of our 29 UHF system. Actually, that's 2 of our 29 UHF systems, 1 VHF system. 23 of those antennas were impacted by the repack. So not a whole lot went unscathed with either one or more changes. So somebody in that antenna is changing. Now some of those are one tenant changes channel, pop out a combiner module and pop in a new combiner module, and away we go. Some of them are not so lucky, including, unfortunately, this antenna, which while broadband did not actually go down low enough to provide a place for the stations to remain. So we probably have one of the 5 tenants being able to stay on that antenna. So there were twists to all of this going along. So while it seems like we use the word broadband antenna all the time, and people say, well, you have a broadband antenna, so why can't you just change channel? Well, all these things had to be considered with that, primarily this VSWR bandwidth, as well as pattern bandwidth. So many of the systems, while they appeared to have good VSWR bandwidth, the patterns, as Nick was alluding to, when you go down from channel 50 to channel 18, which many of these did, the scalloping on the panel and the location of those nulls and peaks changes significantly, and many of the antennas were not able to replicate. So while it appears they're broadband antennas, yes, you can put the power in and it will radiate. It will not meet the replication standards. So we had 4 or 5 of those that fell into that category. I put here number of feed lines, but it's the number and also the design of those feed lines. So some feed lines were built for broadband antennas that weren't also broadband or covered all channels. So all of this had to be investigated in the last 7 months. Right after the table came out, we had a kind of a task force that went through every antenna and understood all the changes and what we're going to do. So, that turned out to be a pretty big undertaking. So as part of our mission, which is to rent space to broadcasters, we determined very early on that, one, we have the expertise to operate these systems. We have 29 of them. Our approach should be to build new systems wherever possible to make this repack as low impact as possible. So we came up with this, what we call the broadband antenna. Oh, I should go back one. So BBA, so I'm now working with the a partner in sales who comes from the wireless industry, and they got to have acronyms. Everything in wireless has an acronym. So as soon as he started, he says, "Oh, so we're marketing BBAs, right?" And I said, "What's a BBA?" So BBA is a broadband antenna. So you only hear, if you call up our salespeople, they only know the words BBA, and SFA, which is single frequency antenna. So, so even the broadcast guys had to pick up some acronyms now and then. Anyhow, so our goal was to optimize the repack changes. So you'll see in a minute what I'm referring to there, but basically we were trying to include as many stations in the design as possible, locate it where an antenna had to be changed. So if we have an open arbor or we have an antenna that we know has to come down, then maybe that's the ideal spot for one. And we're really trying to do this to minimize on-air disruptions. So we're have gone through all of our markets saying, where does it make sense to put up a side mount multi-channel interim antenna? And we found many of those. And we're certainly open to more and more of these. And the goal is really to reduce the overall tower loading. Many of the towers have unused lines and antennas that are left from analog or digital switchovers earlier. And that actually provides us some benefit because we can reuse some of these transmission lines or allow other customers to reuse their lines. So that's good. But the other thing is we're really understanding. So the other thing about our wireless brethren is we get very, very rapid updates on how it's going from the wireless world on using this new 600 megahertz spectrum. So we're very, very acutely aware of how they would like to be able to lease out that space to the 600 megahertz users. So we've said early on to our management, we're going to meet the timelines. It's not we might, maybe, we're going to meet them. We're doing everything we can to make that happen. And, minimizing the overall impact to all parties is another one of our goals. And what I'm going to talk about next is, while we're doing it, hoping to make a future-proof system so that there's some benefit to these customers long term. And that brings us to this, which is, just a word about the word dynamic polarization. So we have two suppliers, main suppliers of broadband antenna systems. There are others, but two primary suppliers of systems who have variable polarization technology and adjustable polarization technology. Between those two suppliers, they have two different names. We were trying to remain vendor agnostic, so we decided to call it dynamic polarization. So it's the same concept. Call it variable polarization technology, an RFS term. Call it adjustable polarization technology, a dielectric term. We're agnostic. It's dynamic. The concept here is to use a slant 45 crossed dipole, and that's the whole key. Is you have this crossed dipole, and you build two independent feed systems for each of these dipoles. So this set of dipoles is fed through one system, and this set of dipoles is fed through another feed system. So we've actually somewhat doubled up the feed system in the antenna. But by doing that, because it's a crossed 45, we can apply full power to both of those terminals and vary the phase between those two terminals and get any combination of H to V that we want. So the takeaway here is that if you want full CP, you put in a 90-degree phase shift between these two dipoles, and you get 50% of the power comes out in the horizontal polarization, 50% comes out in the vertical polarization, and you have full CP phase between them. 90-degree phase. And you can then vary that phase between them. We're actually operating on this side of the curve where the horizontal, per FCC rules, the horizontal must be higher than the vertical. So we're on the right-hand side of this curve. So by varying the phase, we can adjust the ratio between those two. And that turns out to be a pretty handy method for adjusting the polarization. So what we do is, with this is one of RFS's drawings here, we can actually keep the phase constant and kept in phase all the way back to the combiner inputs. So if we put two identical combiners in a row, so one set of combiners here and one set of combiners here, we can actually deliver a signal and split it and add a phasing loop and independently change the ratio of H to V for that channel. So this guy can have full CP, this one can have no CP, can have full horizontal. So this is the first time ever that there's been this ability to independently adjust the polarization ratio. And that's important because the reimbursement is like for like. So if you have a station that had a horizontal only antenna, the only reimbursement they're able to get in the repack is for a horizontal only antenna. But they want to be able to participate at a later date and add another cabinet and add some vertical polarization. This allows them to do that independently from other participants in the project. So so it's really turned out to be a pretty good method to upgrade. So I'm going to show you some what's happened in Atlanta. So these are our stick figures. They certainly are. Someone said to us at a market meeting, this is off because this antenna is really down here. And we said, no, this is a stick figure. It's not to scale. So the point is, the green items are the repacked stations. Black means there's no change. Blue is a winner. And then what we did was emphasize in purple, which you don't see any in this, the repack solution that we have. So take a look at this, right? This is the whole market on our two towers in Atlanta. There wasn't a whole lot left unscathed. There's actually one underneath here that's a low power, but basically the only two full power stations that didn't change on these two towers was WGCL and WATL. So all of the participants on this lower broadband antenna, which we have, I will skip to this slide. So this is an actual photo of these two towers. So this is a pretty unique tower where we actually have two antennas. And this two broadband antennas, this lower antenna here is a dielectric, and this top antenna is an RFS. This was actually built by Richland Towers, and an interesting solution. So all of the participants on this antenna were changed channel. So we developed this concept. And let me just say, this is our Chester Avenue tower, where you kind of notice there's nothing on top of this pole. And there's actually nothing on top of this pole. And there is no pole on the top of this. So there's a fair amount of open aperture on that. So this is just the criteria for that. And the point is, we have to meet this phase 5 completion, and we have 7 customers plus a whole bunch of low power TVs. And we've kind of already talked about all that.
Speaking out of turn, but having worked in Atlanta and being there for the Briarcliff construction, can I just put a quick interjection in? 2 of the stations that are currently on the Briarcliff tower were on the Chester Avenue Tower, including the CBS and the Trinity stations.
Sure.
They were induced, from what I understand, by Richland to move sites. So that's why you have no high-powered TV on that one.
Yeah, yeah,
Can we save comments and questions to the end, please?
yeah. Yeah, so our plan here is to provide an interim antenna and on the Chester Avenue. So therefore, we have a whole separate site that's open and available for those stations to move to, thereby clearing this for us to work. So we think it's a really good solution to allow us to work while we have these stations over here operating independently. And then we end up at our final solution, which is a new antenna over here. Part of our goal was to reuse transmission line and save on transmission line. So we reused the 8-inch line, the two 8-inch lines that fed this antenna. So this antenna now becomes a support pole. And we put up a new antenna here to support these 4 stations. And we think we've got a pretty elegant solution here that works well for everybody. So I'm almost out of time, so I just want to go through this quickly. Things we have to look at, and Nick gave you some kind of background on that, but basically what I've been evaluating is gain. So trying to get the TPOs and add more stations while not making the elevation pattern so narrow that it becomes shooting over the heads of the local population. That's a very big concern of ours. So you kind of have a feel here for gain is one thing. And then, as you alluded to, we are building these replication models, and we asked the manufacturers in the same method to find us a pattern that fits this replication. And that's what this is showing over here. Replication of the Briarcliff facility over at Chester Avenue. So we moved these down and we were able to replicate. So pattern optimization is an important part of this. And then just to show you the other step is to optimize the transmission line. It's got to be fully broadband, and it needs to be large enough to handle the stations, while at the same time, the bigger you go, the more wind load you have. So you don't want to overload the tower. And copper is not cheap either. So I'll just click through these quickly here. The Chester Avenue system is a 12-bay wide cardioid. One of the unique things that we're looking at, since it's an interim main, we wanted to try to do as inexpensive a combiner as possible. So we pre-combining this input and feeding it into a single input on a combiner, but pre-combining these adjacent channels. And we think that's a pretty unique solution, thereby not having to have a separate adjacent channel combiner. These are the power levels for that interim main. You can see they're able to run very high power, almost full power, or even in some cases higher because we're down lower than they were, but still have pretty reasonable transmitter powers. This is the Briarcliff. So the important thing is these are E-pole antennas, so that with the variable dynamic polarization, dual feed systems. This system has a dual 8-inch transmission line and a dual chain combiner. So this is the concept for the dual chain combiners. This is essentially a directional filter model where we have 2 identical sets of combiners, A and B. We split between these 2 inputs and go out to the antenna through this output and this output. The thing about these is these are integrated mass filters, and so you can do adjacent channel mass filtering in the combiner. And that's the power. And that's the last slide. Thank you.